So the first condition that you're given that is the relative velocity along non-parallel lines is also known as relative velocity in two dimensions. In this case, we'll be adding vectors that are not moving in a straight line. So in that consideration, we can use different ways to have the solutions. Can be working with the graphical method. If we can be able to have that on a graph, if it is possible, can work with the graphical method, analytical. We can even do the proper measurements according to a scale and obtain the exact values, which is difficult to have, because remember, in exam you are just given a certain booklet that does it, that is not even having that scale. So that is where we totally put all those graphical method, this and that aside. We are just
Yes,
left
sir.
with analytical way of calculating. I don't know if you're together.
Yes, sir. I understand.
All right. So the question is, how is that possible? All right. So I'm just going to have some short notes here. Then we refer from those ones in order for us to have our relative velocity. So we said relative velocity, but this time we are considering what? Non-parallel lines. All right. So in this case, for you to calculate, let's say we are given a condition to obtain or to calculate the relative velocity. Maybe we are given A relative to B. If we are to calculate the velocity, which is the relative velocity of A with respect to B, A with respect to B, which can also be written as, depending on the textbook that you're using, you can also write it like this, VAB. What is going to happen is that you take what is with respect to B. So you are going to turn B and add to A. With respect to. What is with respect to? We are going to take that, add to the one that we are given original, which is our A. So I want us to go back to this part that I showed you here. We said relative velocity along non-parallel lines is also known as what? Relative velocity in two dimensions. In this case, we will be what? Adding vectors that are not moving in straight. So it's about adding the vectors, combining the vectors together. But how are we going to add now? We turn what is with respect to, you turn that, you add to the other one. That is the concept. Then you apply your components. Are you going to use those horizontal or vertical components? It's up to you.
Yes.
So when I'm saying to turn, it is like this. Let's consider something that is originally given from point O. We are having A this side, and we are having our B this side. They are given velocities. Okay, we don't know their velocity, but let's say we're given those ones. When I'm saying to turn B, this is B here. It is to change its direction. B is going, originally it is going where? To the north. So when we turn B, it is to change its direction. It will be going down, meaning to say we are going to have our B now going to the south. That is to
Okay.
10B. Are you seeing it?
Mhm. Do we
B
do this
up
okay.
originally. So if we say we have turned it, it is just opposing. It is now going the other way.
Mhm.
So let's say we want to turn A. We are going to have A going where? It is originally to the east. So we are going to have our A on this other direction, means we are going to have A this. Let's say it is a condition where we turn A. We are going to have A this side. That is to turn A.
Yes.
So A has been turned this side. So let's say there is an angle between one and the same consideration. Let's say we've got something like this. All right. Let's solve this network. It's not gonna affect. Yeah. All right. Let's say we've got something like this. Originally, this was our A, this one, and this is our B. In between A and B, there is an angle of 60 degrees. In between A and B, there's an angle of 60 degrees. We want to turn B. Where are we going to have B, and what will be the angle in between, considering the horizontal or vertical line? We are going to have B in which quadrant?
We're going to have it in quadrant number 3.
Quadrant number 3. This is the part of B. We're just going to have it facing this side. It was going that side. We are just going to have it this way. That is where we're going
Yes,
to
sir.
have our B. That is to 10B. So from our mathematical presentation, we know or we understand that these two angles are the same, vertically opposite angles.
Yes.
So if this angle is 60, it means also this angle is what? 60 degrees.
60.
So it means we no longer have B where it is originally here. B is no longer, because we have turned it, it is no longer here. It is now on the other side. We are now working with the B, this one. So when you answer the questions, you first sketch what is given from the information originally. Then when it goes to the answering of the question, you now turn what is with respect to. With respect to A, you now redraw a diagram where A has been turned. With respect to B, you now redraw a diagram where B has been turned. You will use your components now to sum, to add up your vectors, to combine, to have the resultant and the angle that is in between. From those components, I think components are easier. From N3, I've been working with components.
Yes, I've been working with components since N3. So
So
it's
that'll
not so
be
bad.
the easier way.
Okay. Because the lecture didn't tell us anything about turning anything. That's why I'm surprised.
Yes, there are, on this one, there are so many ways, but those ways, in some cases, now you'll find out each case, there's an adjustment. When you have a diagram like this, you must adjust like this. On this one, there's no adjustment. You just know it is always with respect to, I turn that one, I apply my components, I'm done.
Okay.
Each and every question that you're going to have, there's no adjustment that you're going to make on this one. There's no
That
adjustment
makes
that
sense.
you are going to make. All right, let's see what I'm trying to say. We going to have an example, then try to have it written down also. According to this information that we are having, it can be when two of the given velocities that you are given, maybe they are perpendicular to each other, or maybe they are separated by a certain angle. So I want you to go through those examples. We'll see. But let's just try a simpler one. Start with this one and see. All right, I'm going to take the first one. Let's hope it's going to be clear. I'm going to take this one, the first one. All right. I don't know if you are seeing the question.
Yeah, I can. Yes, I can see it.
All right, so this is what we are given on this question. We have a simpler question, yes, but it can be useful that we work with it so that it can give us the basics of what is going to happen later on. I'm going to apply that from these simpler ones so that even if we have complicated questions, you see that it's one and the same. An object A is moving due south. All right. At this speed, past a point, while object B is moving due east at 8 meters per second at the same point. This is the information that you're given originally. So if we were to have a sketch, we're going to have something like this. North Pole. Then we have got what? A. Where is A going? Direct to the south. Something like this. Is that so?
Yes, sir.
So this is our A direct to the south at 12 meters per second. We know when it is south, it's going to be a negative. It's fine. Then B is direct. Due east means direct to the east. In the east line, direct going there. That is where our B is, which is at what? 8 meters per second. Direct to the east. So there we cannot answer anything. This is the information that we are given. The diagram has to be altered according to the question. The diagram has to be changed, has to be altered according to the question now that you're given. So the question is, calculate the velocity of what? A relative to B.
Yes.
Which we can write. I don't know if you are comfortable with this one. I don't know which one.
Anyone, I understand. We'll eat both of them, so it's not a problem.
And also the direction. Okay. The question is, are we saying that these two here, they are perpendicular originally to each other? These two, they are perpendicular.
Yes.
Not a problem. We are going to see that if it is perpendicular, all right, let's use the concept that I was talking about from the notes. We said when we are to calculate this A relative to B, we are going to turn B, then we add to A. So meaning to say this is the situation that we are having here.
10B add to
A. So let's turn our B. If we are to turn our B, our diagram is going to be like, how are we going to have our diagram at the end? This is, remember, our B is this
is going to be west.
So we're going to have it direct to the what? The west.
Yes.
This is where our B is now. 8 meters per second. And our A is going to remain as it was. A is not affected. What is affected this time is what? It's B.
B. That changes when it's A relative to B, right? Oh, wait a minute.
On a condition like what?
The other condition where it says
When it is
B relative to A.
B relative to A, exactly. When it is
Yes.
now B relative to A, it means we are now focused on what? On A.
A. Okay,
In this
that makes
case,
sense.
is the B, the A remains as it was.
Okay.
But still, as we can see, we can consider that these two are what? Perpendicular. We say that one.
Perpendicular.
So to use components on this condition where even let's say vectors, two vectors are perpendicular, or this condition where we've got perpendicular line like this, it is a waste of time because this one, it's a straight vertical line. There's no the straight horizontal. I mean, this one, it's a horizontal. There's no way it can change to be a vertical like this.
Can't.
There is no way this one is, we are going to have it vertically like there. It can't.
Mhm.
Same with the A that we are seeing. It's a straight vertical, this one. There's no way that we are going to have it on the horizontal because we do not have an angle which is less than 90 or in between 0 and 90. We are having straight 90 degrees in between the two. If there was a certain angle in between, that is where we can use our components to say, all right, there's a certain angle. This is 8 meters per second. So we are going to need the vertical component and the horizontal component because in between there's an angle there. But when we have
Yes.
it on the east, on the north, on the west, on the south, there we do not waste our time to say what is vertical. It is already presented there on the diagram. It is already horizontal. It is already vertical.
Yes.
So how are we going to have the resultant now and then when it is like this? Where it is already like that. We know, I want you to have this from your N3. Let's say you are
Yes.
using components. You calculate your components. You have horizontal component. It is 2. Which is to the east. Then you have got your vertical component. It is 3, which is to the north. Then you're going to take, all right, these two, they are in the first quadrant. You know that in the first quadrant, you're going to have your triangle like this. Then you put the horizontal component here, which is 2. You put your vertical component here, which is 3. Then you're
Three.
going to say, this is my resultant, and this is what the direction, isn't it?
Yes, sir.
In the first quadrant, if it is in the second, if it is in this one, if it is like that. So here we are saying the horizontal and the vertical, this is how they are. It is not a condition like here where we can say it is like this and this one is like this. How can we have a triangle like this at the end? This is what we want. We see that the resultant that we consider is supposed to be taken from what? From the origin.
Yes.
So this is exactly what we are going to do. We are simply going to take from the origin to where these two meet, to where A, if it was to be taken straight, and B was to be taken also straight, going down like this, where were they going to meet these two? This
Oh,
line
his.
is going to be our resultant, which is this one, the velocity that we need.
Mhm. Like a head to tail diagram is basically what you say.
Exactly. We have to take it from what?
Okay.
From the origin, going where these two
Yes.
meet. So in our normal consideration, as we know that this distance here is the same as this one, isn't it?
Yes, sir.
So this from the origin to A, sorry, this one, the whole of this part, which is the 12 that is the same as this one that we have this side.
Yes.
So we are just going to have it also like this one. So this will be 12 and this will be our 8. So it will be
Eight.
like this, 90 degrees like this. This is the angle that we are going to calculate our theta. We can use this theta here or we can use this one.
I think the
The,
first one is okay.
the theta, okay, the direction. How do you take direction when you are, if you are using the components? The direction you take from the horizontal
Mm-hmm.
side to the what? To the resultant. So
Yes.
if we are in the first quadrant from the horizontal, this one from the horizontal line, horizontal axis to the resultant, are you seeing the angle that we need?
Oh, okay. Yes, yes, yes. I see it.
This is the condition. So what you need is to understand each and every quadrant because it can be in the first, it can be those ones from our N4, those angles
Mhm.
that you were referring as your reference angles from N4, from our N4 maths.
Oh, yes, yes, yes. I
These are the
recall.
ones that we are talking about. That is the one, that is our direction.
Mhm.
Remember, in the first quadrant, your diagram was like this from your trigonometry, and this was your reference angle theta. In the second quadrant,
It's
it was
gonna
like this,
change.
and this was our theta.
Mhm.
In the third quadrant, we're going to have our right angle triangle like this, and this is our theta.
Mm.
In the fourth quadrant, we are going to have our right angle triangle like this, and this is our theta. So this is the same. Are we seeing in the third quadrant? This is exactly what we have here. So this is how you can tell about the theta there. In each and every quadrant, the theta representing what? Our direction now. I don't know if you're together.
Yes, I am.
Are we together?
Yes, sir. I'm following. No, it makes sense.
All right.
Hello? Oh, okay.
So what is going to be our resultant there, which is representing, in this case, our
Pythagoras.
from our Pythagoras, no problem. So that is it.
That's 14.422.
So it's going to be a square root of what? 8 squared plus 12 squared. Is that so?
Yes, sir.
So the negative there, to say this one is in the negative side, it is not important on your Pythagoras there. So what are we going to have?
14.422.
14.422.
Mhm.
Okay. All right. Then what about our theta? Our theta
Um,
angle. Yes. What is going to be our theta here?
okay. Oh, data.
We have
I
opposite
took tan.
adjacent. So arctan.
Yes. Yes.
So that's 12 over 8. And also when, remember, you're calculating the reference angle, the sign is not important to say you are on which side. You just use your values as they are positive.
Yes. Okay. The one that I got is 56.30. 56.3.
56.31. Is that so?
Yes, 31.
Okay, so that is what we are having in this condition. But we need to know exactly from where to where we are having this 56.31. It is in between which poles we are moving from which side going to which side. Which
Okay.
side are we?
Oh,
According to the quadrant where we are. This is the west, isn't it?
yeah.
And this is
Southwest. Oh, yeah, that's the south.
the south. So according to this angle here, theta here, it means we are moving from west going to the south.
To the south.
So
Yes.
it'll be west this angle here. It'll be west 56.31 degrees
56.31
going to the what? Going to the south.
south.
Or
Okay.
maybe you could have used this one from south going to the what? To the west, this one.
That's
You can also
that
use
angle.
it, but maybe you can call it what? Alpha, this one.
Okay.
So meaning to
Just
say you have to subtract it from what? 90 degrees.
90.
You
That's
get that.
33.69.
Is what?
33.69.
33.69.
Yes. Yes.
So we are moving from the south going to the what? To the west.
To the west.
You
Okay.
can have it that way.
Okay. That's not so bad.
That is the condition that you are going to have if we have something that is perpendicular. Already it is perpendicular, this part. So we do not have any adjustment that we are going to say we are going to calculate the horizontal component where we're going to use the cos. There's nothing. We just straightforward on the diagram, but
Straightforward.
it must be on that diagram that we have made adjustment to say with respect to what we Which part? The
So
one
all
that
of this is 10 marks.
this this textbook, I don't know those marks, where were they getting them from?
Yeah, because
Maybe they are trying to tell us in the new coming exams it's gonna be like this. I don't know, because that is what they are showing us. I don't know. Maybe that is going to be the new situation. I don't know.
okay, sir, it's not a problem.
Then the B, the velocity of B relative to A. This time, what is happening?
Uh, this time around, we are turning A and adding B.
So that is B with respect to what? To A. So we're going to turn A, add to what? To B.
Yes.
So the diagram is going to change. The one that we were having here is going to change, but that one is just same situation here. Let me just see the sketch, then we try to have another question because of time.
Yes, sir.
All right, so if we are to turn A here, it means what is going to happen? This is where A is,
A,
what?
it's going to be on the north side.
On the north side, exactly. So we're going to have A this side. So that is our A at what? 12 meters per second. B is
Yes.
not
And then,
affected at this condition, so B is going to remain where it was originally from the diagram.
yes, sir.
So
Then
that is what we are going to have. So are we seeing that is still at 90 degrees? So we're back
we
to,
add our resultant force.
so meaning to say it was going to be what from the origin
Yes,
where
from the original.
these two meet. So it's going to be something like this. Is that
Mhm.
so in the first quadrant?
Yes, sir.
So this is our theta, this is our r. So are we seeing what actually nothing changed, because even our r is going to be from
It's
8 and
the
12.
same.
The
Mhm.
theta also is
Which
the
is,
same, 12 over 8. Are we seeing?
yes,
The
sir. I can
only
see.
part that is going to affect is the direction. What will be our direction? Which poles are working with here?
We're working with north and east.
North and east. So our
Yes.
answer using theta, how can we write our answer? Or using maybe alpha here, because we can also use alpha in between here. I don't know which one is best.
Okay. Either or, but for theta, it's going to be. Give me a second.
For
Uh,
E is going to, for theta is gonna be.
I'm trying to get the value because I erased it here
All right,
on
no,
my side.
let's talk
Oh,
about
it's
theta.
going to be. It's going to be east. Then theta is our 50. What's it? 50 what again? Give me a second.
No, not for 50. Okay, it was 56,31.
Yeah, 56,31. Then it's going to be north,
So it's east going to the what? To the north.
to the north, yes. And then for alpha, it's going to be north, alpha, then east.
North going to the east. So it was going to be north alpha degrees going to the what? To the east, just like that.
Yes. So
So
that
this
one is
is,
33 point something.
which is our
Uh,
remaining 33 that we're
33.69.
given. All right. So this is how these questions can be given, as it is easier. Just try to
Yes, sir.
do as many questions of this nature.
I see number two has our B has 60 degrees
Yes,
west of north.
all right,
Mhm.
okay, let's see that one. Where there is what? An angle in between.
Yes, sir.
All right, let's try what? Okay, let's see. All right, this one. Are you seeing it?
Yes, sir. I can see it.
So we are given there that car A is moving due north. at 70 kilometers per hour. And car B, 60 degrees west of north. What does it mean here? 60 degrees west of north. How
It's
best
going
can we
to,
present that one?
okay, we're going to use our Cartesian, our compass, sorry.
Uh,
It's
uh,
going to
uh, uh,
be in second quadrant,
okay.
west.
It means what? Like, let's say we are saying theta degrees
Mhm.
west of north. What does it mean? Like to the
Oh,
basic that we are used
northwest.
to, like maybe east theta degrees to the south, or north 50 degrees to the east, the one that we are used to, that
Yeah, basically saying goods is going to be in the northwest, if I'm correct.
so it's north going
Yeah, to the
to
west,
the west. So if it is like this, it simply means north theta degrees to the what? To the west.
to the west. Okay. Oh, so we would need to interchange it, not
So
west to the north.
of north,
Okay. Off.
not like of west of north. We work from that off the north.
Mhm.
We are moving from north to what? To west.
Okay.
We are attempting to reach the west from north.
Yes, sir.
So meaning to say this is the condition that we are given here. They are saying 60 degrees west of what? West of north. It
Mhm.
simply means north 60 degrees to the what?
To the west.
To the west. Okay, no problem. No problem. So let's have a sketch first. From our sketch, we were going to have something like this from that information that we are given. They are saying A is going where? A is due north, spread to the north.
Mhm.
Okay, this is our A. Then what is happening with B? We said it's north 60 to the west. This is the west side. So we are moving this way. Is that so?
Yes, sir.
So it is supposed to be something like this. We need 60 degrees from the north going to the what? Going to the west.
Mhm.
So this is where our 60 degrees is from north attempting to the what? To the west. I don't know if we are together on this part.
Yes.
So meaning to say we are having our B like this. So this is the diagram that we are supposed to actually have as our original diagram. Here we know if it is 60, it means here it's gonna be what?
30.
It's gonna be that exactly. Just like so. Let us answer the question now. A, the velocity and direction of what? A relative to B.
Yes. We are first going to turn B.
So we are going to what?
Turn B. So it's going
All
to
right.
be in the
So
fourth
that is
quadrant.
our condition 10B add to A.
Mhm.
All right. So we are going to have our B this side in the fourth quadrant. Is that so?
Yes, sir.
No
Fourth quadrant it is.
problem. Let's see. Let's see. So our A is not affected. It was gonna be like this. This is our A. Then this one, if we turn it, it was gonna be like this.
Yes.
So which angle are we going to use now?
Uh, 30, not 60.
We are going to
Because we're
use,
looking for 30 from the horizontal.
oh,
Yeah, the
this one.
horizontal line. Yes.
All right, all right, all right. I see this one. Okay. If it is like this, we are together.
Mhm.
So this
Please
is what
indicate.
we have.
Okay.
The original diagram is now affected due to, according to the way that we are given,
Hmm?
the way that we are given, that it affects the diagram that we had before. So the sketch is important. Then we have the one for the question now. So this is our question. We need to determine velocity, which is just the resultant in actual sense, because we have to use those components, and also the direction.
In this
This time,
situation,
uh,
are we not supposed we can't use Pythagoras, right?
exactly. It's now, yeah, are you seeing it is no longer applicable this time, because it's the lines that we are having are not in the first or second quadrant where we are creating, where you are having a 90 degrees in between.
Yes, sir.
The
I can
angle
see that.
in between these two is no longer 90 degrees. So that is where now we can go to those cosine rule, depending with the way now that you understand. Maybe if you're doing physics, you understand those head to tail. I don't know. If you are using
No,
components, I don't
yes,
know.
no. I think it's best if we use the cosine rule. I feel like that would be easier.
The cosine rule.
Yes, because I need to be going to add our 90 plus 30 and have an angle to find the resultant. Am I wrong?
All right. It's okay. I'm not saying it's okay if, even if you are to use the cosine rule, but
Okay.
for the basics of what we had before, because we had something that was similar to the components
Oh,
which we used with, relative to those quadrants, to say what is it going to be in each and every quadrant. You're going to verify with the cosine rule, all right? Then we'll see from there. But let's say we were to use your components. When using components, you simply need the horizontal component and the vertical component. These are the ones
oh,
that you now take to the quadrants to say, okay, in which quadrant are we having that horizontal component that you obtained? In which quadrant we have the vertical component? That is where now those quadrants are playing a role to say in which quadrant are we having horizontal being positive, or this one being positive, according to the answers that you're going to have here.
yes. Okay, that makes sense.
So it was going to be easier that way. What is the horizontal component that we are going to have for 100? Or you can
Going to
even,
be
okay, for 100, what are you going to have? It's going to lie here. So it's going to
yes.
be 100 cos
Uh,
of what? Cos 30, is that so?
yes, cos 30.
The angle that is in between the horizontal line, this one.
That's 86.603.
Can we use A here on this part of horizontal, where A
Mm,
is directed 90 degrees like this?
I mean, it's going to be zero.
It's going to be
Cos, yeah,
0.
yeah, it's going to be zero.
So
Cos
even,
90 is equals to zero.
exactly. So even if we're to write this one, there is no need, because that one is what? It's a 0. All right.
Yes.
So it is good to notice that one. So what is the value for this one? 100 cos 30?
It's 86.603.
86.603.
Yes, sir.
Then we take the vertical. The vertical, what is going to happen on 100? Or you can start with
Yes.
the A,
Okay. It's going to be 70
70
sine
positive.
90. Yeah,
Okay, sine 90,
that's
no problem.
yes.
That's 990 is same as what? A 1.
One. Yes.
All right.
And then
So then what about the 100? What is happening?
100 sine 30.
It's going to be 100 sine 30, where it
Isn't
is, but
negative.
negative there. So it's going to be negative 100 sine of what? Sine of 30. So you
Yes.
just use your components as usual.
Yes, sir.
That is the condition that we are having there. All right. So meaning to say our vertical component was going to be
20.
20,
Yes. I
20,
hope I'm
20,
right.
20, 20 like this.
20, just like that. Let
Okay.
me punch in again.
So, okay, 70 minus
And
50. Yeah, that's it, 20. So this is what you're going to have. So according to the horizontal being positive, it means which side are we going? Horizontal line.
going to the east.
We are going to the east. Vertical
Yes.
being positive, it means we are going where?
To the north.
To the north. So that is the condition that is important here to say. Where exactly do we have the horizontal? Where exactly do we have the vertical? So that we know the quadrant that is going to lie our resultant.
Yes.
So in which quadrant do we have horizontal being positive, vertical being positive, or which quadrant do we have east and north at the same time?
That's our first quadrant.
That's our first quadrant. Where we have east and north, it is happening in the first quadrant. This is our north, this is our east.
Mm-hmm.
So in the first quadrant, how do you present the triangle? We are back to those triangles that we're having, those ones. In the first quadrant, our triangle is going to be like this from our trigonometry.
Yes.
This is our horizontal, this one. So we have this horizontal value 86,603. This is our vertical as it is, which is our 20. So when we have this, the resultant, which is in this case, our relative velocity of A relative to B, this is the one that we are having here. And the direction is this one, our theta.
Mm-hmm. Yes.
This is the final diagram that gives us the resultant end. So I want you to, because of time, I want you to work out using those here to tell the 12, what that we have,
Yes.
cosine
I, al-
rule.
I already found the answers for the resultant. It's 88.882.
It's gonna be
88.882.
88.882.
Yes.
Okay.
And then
Then the
the
direction,
data, yeah,
arctan,
the data, it is, give me a second. That is 13.004.
13.004.
004. Yes.
So from where to where?
East to north.
East to north. So that is
Yes.
east 13.004 degrees to the north. So that is how these questions can be given as what you just need is to work out as many questions as you can.
Yes, sir. That is not
So
a problem.
yes, that one it needs practice, more
Yeah, because
practice.
I realized my mistake and what I didn't understand. It's that turning, because I would just do calculate and the answers would be off because
I
of that.
I see that one. So yeah, try this method and see if it is easier. Try to
Yes.
apply it on questions like this when you are dealing with when you are working with relative velocity.
Yes, sir.
If maybe it can be some other questions where we do not understand. Let's see. We'll just work all those ones out and see. But
Okay.
yeah, for now, I think yeah, this is the one. Just try to do more questions and also try the same question because as you can see on this one,
Yeah,
we
we're not done.
yes, we
Yes.
have another one. So I want you
But eight.
to now try
Mhm.
working with what? B relative to A.
Relative to A. Okay.
So
That
then
is
you
not a
say
problem.
we have to turn A, add to what? To B.
Mhm.
We apply normally as usual all those the components as it is. You just find horizontal, vertical. So this one is just direct horizontal, vertical. You're back to this one. Which quadrant
Yes.
are we going to have our final answer? The quadrant gives us everything, resultant, and the direction is there in that quadrant.
Mhm.
So
Yes.
just try. Yes, I'm not saying the use of the cosine right at the end. I'm not saying it's wrong, but there are adjustments that you also have to do on the diagram, especially on its own, to
Oh,
say where am I going to have my resultant, where exactly am I going to have the direction.
okay.
But the
Now I'll just
quadrant,
stick to this one then.
yes, the quadrant, they exactly you know if it is in the first, those ones, your reference angles, the one that you did in maths.
Yes.
Those reference angles, those are your directions.
Okay.
So you know that if it lies in third quadrant, I am already, the direction is already there. I don't have to struggle to say, well, I'm going to move from which side, going to which side. Okay.
Oh, okay. Yes, sir.
So we are going to add more questions, but for now, just try to work out those ones from that activity. You said this one you have it, this textbook, can't?
Yes, I do have it.
All right. So try to have more questions. There are so many questions there. So
Yes, sir.
many questions on this one. So many. Then we'll see from there.
Okay. Thank you so
Oh,
much, sir.
all right. No problem. You're welcome.
Have a good day.
Okay. Same to you. Let's revise more on question papers also.
Oh, yes, I'll prioritize them.